Welcome to Study Guides Forum. So today we are looking at a question, a very important question for candidates that are preparing for WAEC, NECO, GCE and other related exams. This is more of a practical titration. In this question, it says S gram of anhydrous sodium trioxocarbonate was treated with 1 mole but treated with 1 dm cube of 0.2 mole per dm cube hydrochloric acid to obtain A. B contains 0.1 mole per dm cube of sodium hydroxide solution. Now the other process, I skip it here. I don't want to, because of space. That has to do with how you do the analysis. That is adding the acid to the base, then where we talk about the indicator tabulation, which I have done, and then record all these values which I have done here. So after that, the next thing you will see is that from your results, this result I have here, and the information provided, which is this other one, information provided, calculate the amount of sodium hydroxide in 25 cm cube of B. B is this one we're looking at, 0.1 mole per dm cube. Now, the second question is concentration in mole per dm cube of the acid that reacted with sodium hydroxide. And the last one is mass S of anhydrous sodium trioxocarbonate in grams. Now we have the equation of the reactions, the first and the second equation of the reaction. Now, to start with, the first thing we're going to do is to finish up our business with the table. In this table, we're going to use the table to calculate the first thing you do is just to use it to calculate the average volume. You're going to get the average volume of the A used. So to do that, we're going to select the one that is very close to each other. Then when you look at this, you can always select the one that is, at least from what I have here, I think I can go with 1, 2, 3, because their differences are not so much, and they are not far away from each other. So it's a difference of, I think what I have here should be a difference of plus or minus 0.1. So the difference of, that's what they are. The highest, the maximum is 0.1. So we can go with all of 1, 2, 3 of them. So to get the average volume of A used, what we do here is just like the way you calculate your mean. Average volume of A used is equal to, that is 27.10 plus 26.10 plus 26.20 all over, because there was 1, 2, 3. We divide what by what? 3. So when we do that, we have 27.10 plus 26.10 plus 26.2. What we have will be 79.4 divided by 3. When we divide it by 3, what we have is what? Equal to 26.47 approximately cm cube. That is what we have as our average volume of AU. So we'll keep it somewhere and start doing our work. Perhaps we can now clean here to make space for other things we want to do. So the next thing we have here, the next question we are done with the table now. Let me just keep this thing here, because we always come back to it. So the next thing we are going to be doing here will be said the amount of sodium hydroxide in 25 cm cube of B. Now, what if you want to get what we have here? 0.1 mole per dm cube of sodium hydroxide solution is the one that's in dm cube, in 1 dm cube. Now we're looking at what we have in 25 cm cube. To do this, we're talking about amount of sodium hydroxide in 25 cm cube. So what we do here, we know that in 1000 cm cube, we have what? 0.1. Then 25 cm cube will then be 0.1 over 1000 times 25 over 1. So that will give us equal to 0.025 moles. Is that what we have? No, it should be 0.5 moles. So let me just assume that alright, I think I'm correct. So this is what we have for the concentration. For this first one, we have 0.0025 mole in what? 25 cm cube. There's another method we can use to solve this, where we use concentration C amount over volume, where this C stands for what? The concentration, this concentration, which is 0.1 mole. Then amount is the what we are looking for this 25 cm cube. We say is what? M. Then this one stands for amount. So this volume now is for 25. Then we'll convert it to dm cube. 25 divide by 1000. It will give us 0.025 dm cube. So what we have here will be what? 0.025 dm cube. So making n the subject of the formula, we have 0.1 times 0.025 dm cube. That will give us 0.0025 watts a mole. That is what we have. So this is another method of doing it. Remember this, either you use this or you look at the proportional, you use the proportional method or the formula method. Any of the one you think is okay for you, that will be faster and easy for you, is also nice. So we go over to the next question. The next question here says that the concentration in mole per dm cube of the acid that reacted with sodium hydroxide. So in this case now, we are going back to the regame of the remit of the matter. In the remits of the matter, the next thing we are doing now is what? Concentration. Concentration of what? Concentration in mole per dm cube of what? The acid, sodium hydroxide, hydrochloric acid. I can leave it here. So in this case now, this is when you will use our formula, which is CaVa over what? CbVb equal to mole ratio, the mole ratio. Where this other one, Ca, is the one we are looking for, can put question mark on it. So the volume of this A is this very one we reserve here. So we have it to be that one we have in our reserve bench. So we are calling it into play this time. So here we have Cb is equal to 0.1 mole. So Vb is then 25 cm cube, which is actually what I used. The pipette I used in doing this is 25 cm cube. So that is what we have here. So it serves as the volume of the what? The base. And the indicator I use is methyl orange. I just want to let you know about it in case you want to try something like this. at home or in your lab. So the next one we have the mole ratio. The mole ratio, we'll get it from the balanced chemical equation. The balanced chemical equation for this very one we're looking at is what? You see that here we have 1:1 because there is 1:1 because there is no coefficient. There's something like 2 here, 2 there, there's no coefficient. Just like what we have here, 2, and this one that has no number here, we say is what? 1. So in this case, this one has no number here, no number there. So we say is what? 1:1. That means the mole ratio, this one is equal to 1. This other one is also equal to 1. So to solve this problem now, we have everything we need to get the value of what? This Ca. So now pay attention while we solve the problem. So we have Ca is times 26.47 all over 0.1 times 2.25 equals 1:1. So when we cross multiply, now we have cross multiply this one, we multiply what we have under. Why this other one, this Ca multiply 26.47, we multiply this one which is under here. So if that's happened, we can have something like this 26.47 C equal to 0.1 times 25. So in that case, Ca will then be 2.5 all over 26.47. So let's see what we get there. And we have a 2.5 divided by 26.47. What we have is approximately 0.0944 moles. Now, this is for what happened in this reaction. And remember, we have two reactions that took place in this very analysis we are doing. The first one has to do with acid and sodium hydrochloric acid and sodium hydroxide. So now I want to take you back to the statement we have here. In this statement, it said S gram treated, S gram of anhydrous sodium trioxocarbonate treated with what? 1 dm cube of what? 0.2 mole per dm cube of hydrochloric acid to obtain A. That means now you cannot put this sodium trioxocarbonate there without any effect. The moment you put this thing here, it means that some of them will react to liberate carbon 4 that we have here, water and sodium hydroxide, sodium chloride too. So this is actually another side reaction that happened before we were able to do our titration. Note very well. So now, how do we get this in? The question said we should get the mass of what? X. To get this mass of X, the S mass, what we're going to do now is to find out the number of moles that reacted with this. Because what we have here is the mole that reacted with the sodium hydroxide. So what are we going to do? In the main reaction, in the main concentration, so let's see how we're going to, let me keep this one here too, because this one is going out entirely, because we are done with it. We are going to put this one also in the reserve bench. Let it be on our bench this time, so that we'll come back. When we come back, we'll pick it up. So now to solve this problem, I think that's the basic thing we need from all this calculation we have done. So here now, so what we are doing again is to solve this number 3, which is mass X of anhydrous sodium trioxocarbonate 4. So to do this now, the first thing we know that in this acid, original acid, the initial acid we have here, amount in the initial, let's use initial here. Initial hydrochloric acid is what? 0.2 moles. Amount that reacts reacted reacted with sodium hydroxide is equal to 0.0944 mole. This is, we are calling back our man in reserve bench into the game, which is 0.0944 moles. Is back to the game. So now what else are we going to do? We need to find out the mass, which means this is the one that reacted with this, which means if we subtract to get the amount that reacted with what, the trioxocarbonate amount that reacted with sodium trioxocarbonate 4 will give us 0.2 minus 0.944. That will give us, let's see what we have here, minus 0.2. It will give us 0. Am I doing 0.10? Let's leave it here, 6 moles. Let's just leave it there approximately. So what next are we doing? Now we have the amount that reacted. Now we'll go back to this chemical equation. Note this equation that we have here. 2 moles of hydrochloric acid reacts with what? 1 mole of sodium trioxocarbonate 4. From that statement, it means that 2 moles of hydrochloric acid is equivalent to what? 1 mole of what? Sodium trioxocarbonate 4. Now we know that 1 mole of this sodium trioxocarbonate 4 is also equal to what? The relative equal to the molar mass or relative molecular mass, relative molar mass of it, which we can get by sodium trioxocarbonate 4. We have sodium to be what? 23. 23 is sodium. That means 2 multiplied by 23. Why am I multiplied by 2? Because of 2 is here. Sodium is 2 in this compound. Now we have another one. Carbon is only 1. We have carbon to be 12. Then oxygen is how many? 16. That means 3 multiply 16 because of the oxygen is 3 there. So when we add it, multiply through, we have I think that's what we should have. This multiply that will give us 2 times, no, it should be 6 here. This will give us 12, and I think this one is the one that will give us 48. This is the one that will give us 48. 16 times 3. 16 times 3 will give us 48. Yes. So when we add it up together, add everything together, we have 106 grams. Let's go by that. So this is the main thing we are going to be using in this case now. Let's go back to business. I think we are going to finish it up from here. Now from here, it means that 2 moles is equivalent to is equivalent to what? Now 1 mole, which is equal to what? 106 grams. Because we are looking for the grams, I just want to see how we're going to make it faster. Which means if it's so, we can then go ahead to say that 0.106 mole will be equal to 106 over 2 times 0.106 over 1. So now notice what I did. Because this 1 mole is equal to this, then since we are looking for the mass, there's no need working with this. Then we can also go directly towards using the relative molar mass of it. to do the work effectively. So now when we do that, what we have will be divide by 2. We have the mass is approximately, you can say 5.62 grams of what? Of sodium trioxocarbonate 4. That is what reacted. Now you can see how simple this seems to be, but there's something you should always pay attention to. You should also remember that before you can get this thing done, it's important to really apply this, get the amount that reacted with it. So thank you for coming this far, and if you have any question, you can leave it in the comment section. I will always attend to your questions. And if you are joining us for the first time, welcome to Study Guide Forum. And then remember to share. Don't forget to share so that some other person can get this in and enjoy with you. Then if you are coming for the first time, so subscribe, and then thank you, and then we're looking forward to hear from you. To be together again in our class.